Hello everyone. Today we are going to study about device drivers. The study is based on the following aspects of device driver. One is usage aspects of device driver. Second is the role of device driver for communication between device and a computer system. Third is the plug and play technology of Windows operating system. Fourth is the support provided by Linux operating system to facilitate device driver development. Fifth is the device driver installation and troubleshooting. So, we start with, as we have studied earlier, a large number of devices can be connected to a computer system. The device can be internal to the desktop like hardware devices providing USB, serial and parallel ports. Hard disk controller, sound and video cards are internal devices. The devices which are connected over these ports are called external devices. The operating system is used to configure the devices connected to the computer system. The programs called device drivers are developed to communicate with the external devices such as monitors, printers, keyboard, mouse and scanners. Most operating systems today have built-in drivers for the most commonly used peripheral devices. The operating system looks for new devices if connected during the boot process. If a new device is found, the operating system tries to install the appropriate driver in order to get the new hardware ready to use. Once the driver and device is properly installed, it is preferable to test the device using a sample run. In case of a printer device, the output is available in the form of a test page. The line printer produces a test to verify if all the characters are printable on the width of the page. As the line printers are available in two widths, one is 80 column printer or 132 column printer. However, if a driver file is corrupt or damaged, it will no longer work and requires troubleshooting. The operating system during the boot process recognizes the malfunctioning of the device either because of the driver hardware or the damage in the driver software. If the hardware is faulty, the customer support engineer is called, else it is notified to the end user that driver needs reinstallation. The user can then reinstall the driver either from the installation disk or CD provided with the hardware, device and the manual. The driver software may also be made available by downloading it from the manufacturer's website. The important thing is the new driver must be compatible with the version of the operating system installed on your desktop. Sometimes when a new version of the operating system is loaded on the desktop, the driver also needs upgradation. The operating systems like Windows automatically check from Microsoft website if any patches are to be applied on the operating system. The patches are applied to the operating system as well as to the device drivers if the changes are made in any one of them by the developers based on the user feedback. Therefore, sometimes if you are working on an old desktop, loading new version of the device driver from the internet does not work. Rather, the installation disk provided with the device manufacturer helps to reinstall the device driver. Next, an added feature related to the device driver is called plug and play. The plug and play technology was developed first by the Windows operating systems. It allows the devices to be connected to the computer system with no or little manual intervention. The technology facilitates the connection of a device to the computer system without the user worrying about the installation and registration of a device driver. It requires support from both the operating system as well as hardware manufacturer. The technology enables a computer system to recognize and adapt to a hardware configuration changes with little or no intervention by a user. A user can add devices to and remove devices from a computer system without manually updating the configuration details or installing new device driver for the same. For example, user can attach a wireless keyboard, a wireless mouse, USB or monitor to a smartphone device without making manual configuration changes. Plug and play requires support from device hardware manufacturers, system software developers as well as the driver developers. Initiatives in the hardware industry like defining standards such as PNP, ISA definition and the PC card standard in the desktop for easy identification of add-in boards and basic system components is available. The Windows driver kit, in short called WDK documentation, focuses on the system software support for plug and play and how drivers use that support to implement plug and play is available. The system software support for plug and play requires that the PNP drivers and applications must have a mechanism to detect changes in the hardware environment and take appropriate action keeping that change in mind. The plug and play technology should detect which drivers are required to support each device and loads these drivers either from a CD-ROM provided by the device manufacturer or directly from the device manufacturer's website, which recognizes if the device is a genuine product and will permit such an installation based on the registration number. Next, we discuss the support for creation and installation of a device driver in a Linux operating system. For security reasons, the operating system code even today on mainframes and higher end machines is not put under public domain. It is accessible only to a small number of programmers who are trained to maintain and add new functionality in the operating system. As the Linux operating system was developed in an academic environment with support of a large number of academic institutions, is open source. That means, the source code of the Linux operating system and all its internal functions along with their input output interfaces are available in public domain. Therefore, it is now readily examined, understood and modified by anybody with requisite skills. The Linux operating system is complex piece of code and is difficult to understand without appropriate training. The operating system like Linux supports a variety of hardware platforms including different CPU architectures like MIPS series of RISC architectures, 68000 Motorola architectures, etc. The operating system is written in C language. It has to be compiled so that it generates code for the architecture where the Linux operating system is going to be installed. Also, it provides support so that end user can interact with various devices using simple commands. It also provides a framework and interfaces so that future device manufacturers can easily develop programs for the device interaction with the operating system. The operating system code provides interfaces where the third party device manufacturers can attach their code so that the operating system is able to send and receive data to and from the device. The piece of the code written by the device manufacturer providing the above functionality is called an device driver. The operating system provides standard programming interfaces for the users to interact with variety of devices. A device driver is a software module that enables communication between a user process and a peripheral device. It may perform some or all of the following functions. First, take the device online and offline is the first task performed by the device driver. The second task performed by the device driver is set parameters in the device. The third task performed by the device driver is transmit data from the operating system to the device and receive data from the device and pass it on to the operating system. The fifth task is handle and report I/O errors. Sixth task is handle exclusion and other multi-user multitasking arbitration. In other words, the device driver is a special software that makes a particular piece of hardware respond to a well-defined internal programming interface. The user is not required to deal with the complexity of handling the device. User activities are performed by means of a set of standardized calls that are independent of the device specific driver. These standardized calls by the user are converted into device specific calls that act on the hardware by the device driver. This programming interface is such that the drivers can be built separately from the rest of the operating system and attached to the operating system as and when needed at runtime. The open source nature of the operating system like Linux facilitates easy learning of how to develop device drivers. Also, it gives opportunity to device manufacturers to make their devices accessible through the Linux operating system. The another advantage of the open source software is that it gives the opportunity to the end users to find out the potential flaws in the source code and identify portions of the software which are running slow and therefore have scope for performance improvement. In that manner, the Linux operating system has contributed a lot for the development of device drivers. Another important point about the device drivers is that their role is providing mechanism, not policy. The distinction between the mechanism and policy can be described as the mechanism deals with what capabilities are to be provided and policy deals with how these capabilities can be used. Therefore, the device driver deals with what capabilities are to be provided for the device interaction. For example, the mechanism to check for in a printer device could be power on off. Second, device status is okay or not. The third thing to check in a printer device is to check whether the paper is there or not there. Fourth thing is to check whether if there is any paper jam. Fifth is to check if it is able to send data. And next is whether it is able to receive acknowledgement after successful print. The seventh is the request to send next block of data are the basic mechanisms available in a printer device. However, the policy of how a printer device could be used may be as follows. First is selective printing. As you might have seen, when you want to print something, you want to print a file to the printer, you have the option available. Do you want all pages or you want some selective pages? So, selective printing is one option which is used, that you want to print only 3 to 10 pages required out of the 20 pages available in the file. You can also specify how many copies of the print you want. You can also specify how many pages per sheet you want. You can also specify the selection of different type of paper sheets like A4, A5, executive paper or different paper sizes also you can select while printing. You can specify whether you want your print to fit into a specific paper size. You can also specify margins like top, bottom, left and right side. These days you might have seen in a Windows environment that the policy on how to use the device capabilities like printer devices are made available through a Windows common framework, and the mechanisms are developed by the individual printer manufacturer. The another example distinguishing mechanism and policy is taken from the display of Unix operating system. The Unix operating system provides a hardware abstraction layer for graphic display, which provides a unified interface to the user programs. The layer encapsulates the hardware functionality so that the end user need not know any of the hardware details for the display. The window and the session managers responsible for the Windows and session display also need not know about the hardware. The Windows manager implements a particular policy without knowing anything about the hardware. A Windows manager developed on a particular hardware instance of Linux is also usable on other platforms without changes, and different users can run different configurations on the same workstation. Take another example derived from a floppy drive. The device driver software is developed in such a manner that it provides the user the facility to read blocks. The information of the hard disk is divided in various concentric circular tracks. Each track is divided into sectors. The information of a sector is divided in blocks. However, the driver software treats the entire floppy disk as an array of contiguous data blocks. The driver software written for a floppy drive shows the diskette as a contiguous array of data blocks and provides read and write operations on the data blocks. The higher levels of the system provides policies such as who may access the floppy drive, how to detect errors by introducing checksum, how to improve the reliability so that in case of failure of read write operation, information may be transferred to the alternate blocks, how to create directories, subdirectories, and in general the file system, how to keep the system of files secured by encryption or by password or the policies issues, which are taken care of by the operating system. The complex software is needed to accomplish the above. However, it uses the basic programming interface provided by the device driver and protects the operating system from the complexity of handling a floppy disk drive. When writing drivers, a device driver developer should focus on how the hardware may be made accessible to the user. It depends on the user and the application developer how they want to use that hardware, since different users have different needs. So, what we have learned today is the role of device driver. The examples of device driver for the printer and other devices are explained. The role of the device driver and the Windows technology of plug and play was discussed. The support provided by the open source nature of the Linux operating system for the development of device driver was explained in brief. Thank you.